Hi guys, this is Magnetism Review Part 2. Okay. So the first thing we're going to talk about here, the first thing you need to know is the Biot-Savart Law. Okay. And this one states that the particle dB will be equal to mu naught I over 4 pi times ds crossed with r spectra, then r squared. Okay, so our first conclusion was if we had a wire and want to find the magnetic field at this point, let's call it P. Okay, so there's derivation for this guy here, to find the magnetic field at this point, but I'll not go through this now, but I'll give you just the results for this one. So we got I mu naught 2 pi, if we said this distance is r, so it's 2 pi r. Okay, so this is for a magnetic field from a wire. Okay, the other thing you need to know is let's find the magnetic field at the center of a loop. Okay. Alright, so we have a current that's going this way, and we need to find the magnetic field at this point here. Okay. Alright, so we're using the Biot-Savart law to find it. So let's call this small ds. Okay, and the direction of it is going this way, because the current is going this way. Okay, so where is the r here? The r will be from here to here. Okay, so ds crossed with r, so the magnetic field will be pointing out of the screen. Okay, so B is out of the screen here, so B is out of the screen. Okay. Alright, so let's use the Biot-Savart law. So dB will be equal to u naught divided by 4 pi, and then so now the ds crossed with r, so it's going to be perpendicular to it, so it's going out of the screen, so it's ds over r squared. Okay, you can see here that the r is not changing, right, as we go around the loop, right? So we need to count all the ds's here, so we'll do the integral. So integral of dB is just b, and u naught I over 4 pi, and the r squared is not changing. The r is not changing as we go around the loop, so it's going to go out to the integral, and then integral of ds. Okay, so the ds here, if you go around it, it's just 2 pi r, right? So take it back here, we'll get b equal to mu naught I over 4 pi r squared, and then it's 2 pi r, right? Let's take out the r, take out the 2 pi, so your result will be equal to mu naught I divided by 2r. Okay, and this is the magnetic field at the center. Okay, if you want to memorize it, but here's the way you differentiate this guy. Okay, so the second one is if we had this circle and we need to find the magnetic field that is it's out of the screen, it's here. Okay, it's somewhere here. Okay, so if we look at where's my phone? Okay, use this guy. So here's the circle. Let's imagine that this is the circle, and we need to find a point that's here. Okay, which is, if we flip this guy like this, it's kind of here. This is the point we're looking for. Point right there. Okay, it's on the axis of the circle. So if we look at the circle from the side, you're only gonna see this like this. Okay. Alright, so the current will be going this way here, so it's kind of going out of the screen here, so So it's dot, and here it's going x, here it's going down. Okay. So the axis of this circle, it's around the center. Okay. So we need to find the magnetic field, like you find an equation that we can use to find any point on this axis. Okay, so same thing, we can use the Biot-Savart law. So we'll take a piece of ds, that's here. So this is ds, and our r will be, like, let's say we're gonna take it to this part. So ds will be pointing this. So the magnetic field will be pointing, right, I'll give you a second to guess. Where is it going to be pointing? Remember, it's ds cross b, right? ds cross b, ds cross r. Okay, so it's going to be pointing this way, right? And if you use your right hand rule, your thumb with the ds, okay, and then curl your fingers with on the dr, then this will give us the direction of the magnetic field. Cool. All right. So we're gonna have also the s here. If you notice the ds, it's gonna have the same thing, perpendicular. And you can see that the y component here is canceling, right? So they're gonna cancel each other. So we will be only looking at the cosine of the this dB here. Okay. So let's use the Biot-Savart law. So dB will be equal to u 4 pi, and then ds over r squared. And we're taking the if we say that this is x, this is y, so we're taking the direction of dB in the x direction, right? So dBx will be cosine of theta. So if we say that this is theta, this is 90 minus theta, so this is also a theta. Okay. So let's take let's make it like change these to another variables. So r squared, if we say that this is r and this is a big R and this is the x-axis, so I'll call this x because it's changing. Okay, so r squared will be r squared b is Pythagoras. Okay, so it's r squared plus x squared, right? ds, and change the cosine. Cosine of theta is r over the small r, so it's big R over small r. Okay, and let's change this r2 to the r squared and x squared. So it's gonna look like this now. So it's I u over 4 pi, and then let's take the ds, and we're taking the integral, we're taking around the whole circle, so let's do integral of ds. All of them will not change. Okay, so what do I want to say? Yeah, so when we do the r squared, the r here will be equal to the square root of r squared plus x squared, right? So when we add those together, we're gonna have r squared plus x squared to the power 3 divided by 2. Okay, and we have here the r. So then the integral of ds, it's a circle, so it's 2 pi r, right? Let me see. Okay, so it's 2 pi, and then the big R, and then so we have here r, then r squared plus x squared to the power 3 divided by 2, 4 pi I mu naught. So we get to cancel those. So we're left with I u naught r squared, right, divided by 2 r squared plus x squared to the power 3 over 2. Cool. Okay, so this is the Biot-Savart law. This is what I think you need to know.